Okay, welcome to what is ostensibly day 8 of Advent of Code. Um, Unfortunately, the recording that I tried to make of me doing day 8 live didn't get saved, and I'll talk more about that, I guess, in the reflection on day 8 that I'll do in just a few hours. But I figured, just so we had a video for every day, it was worth me capturing my reflections on day 7 and then giving a little recap of how day 8 went, because actually it was kind of interesting. I did not program the right problem. But we'll talk about that in a minute. Let's start with looking back on day 7, because there are some interesting things to say, even though day 7 was very, very simple. So, looking at my reflections. So, it's now been more than a day since I watched the day 7 video, but I recall thinking out loud, does Swift have an average function? And I still don't know if that's true. But Swift does have a reduce function, and like any Swift programmer should know how to use reduce the same as they should know how to use map. These are two rudiments of the language, right? So if you want to compute a total, you just call reduce, and the first argument is like the anchor value, and then plus is just how you add all the elements of a sequence together, right? Apologize for the noise. The dog is having fun because it's daytime now, and she isn't just happy to go to sleep. So we should remember to use reduce where applicable, and I'll actually have more to say about that later on. When I was doing the problem, my first instinct was that the position that all the ships should move to would be the mean of their positions. And in fact, for the first part, when the fuel cost is just the distance that they have to travel, the correct answer is they should all move to the median ship position, not the mean ship position. Whereas for the second part, where it's more like the square of the distance, then they should move to the mean position. I spent a little time yesterday now coming up with analytical proof that was the case, and I did manage to get what seemed convincing to me, but I still am not crazy about the intuition behind it. There must be a very intuitive reason why one is the median and the other is the mean, but it hasn't jumped out at me. So maybe I'll keep thinking about it, maybe I won't. But once we realized we were getting the wrong answer, we moved over to let's just try all the positions. And, that sounds like a stupid approach, but in fact, this is something that it took me until kind of absurdly late in my programming career to get comfortable that computers are tools with certain advantages. And sometimes this kind of approach, just brute forcing a problem, it will get you the right answer, and it's actually much more robust than some analytical technique. Because in general, if there's an analytical solution to some complicated problem, it only takes a very small perturbation in that problem for the analytical approach to completely fall apart. Whereas if you're just, throwing a lot of computing horsepower at it, doing a lot of samples, and that kind of thing, generally that'll work no matter how complicated the problem gets. So being comfortable with brute forcing thing is actually a good thing for people who want to use computers to solve problems to do. And it was actually doing 538 has this weekly thing called the Riddler that I did for a while when it was run by a different editor. And those aren't programming puzzles; they're kind of general mathy puzzles. But they're ones that I always tried to solve by writing a little program that kind of threw a lot of horsepower at the problem, and then gave me an answer as a result of just doing a bunch of tests or something. And anyway, so props to that. I have no idea whether they're any good anymore because I don't do them anymore. But if you're interested in general puzzles that you can use computers to help with, but aren't focused on programming specifically, look into 538's Riddler. Also in Swift, and this was just because my brain wasn't working super well. Swift does have min and max functions for sequences, but in Swift they're members of a sequence. And the thing is, uh, the language that I am most familiar with is C++, and in C++ there's actually a very kind of complicated culture around what should be member functions versus non-member functions, and when you should use inheritance versus overloading versus a combination of the two where you dispatch between the two types of things, and I think there's been a fair amount written about that, and a huge amount of experience digging into the strengths and weaknesses of each of these approaches in C++. Will teach you which is right. C++ does not have Swift's extension mechanism, and the fact that in Swift anyone can extend types they don't own with additional member functions completely changes the dynamic of where functions should live, whether they should be global or live within the structures that they operate on. And I still don't have a very good intuition for that, and I would love for someone to write a kind of advanced Swift book that talks about the culture of Swift and kind of style things and, how you make these kinds of decisions. I actually had one little project I did shortly after last year's Advent of Code trying to get some kind of general polymorphic dispatch that in C++ you would do with a combination of overloads and specializations and that sort of thing. And I could never quite get it to work in Swift because there were so many different ways to do it. And Swift has these weird things about tuples versus arrays versus real classes and structs. And anyway, yes, but the short thing is that min and max are members, and you should know how to call min and max on a sequence. And I did know that, but I didn't actually do it when I was solving the problem. Stupid things I said briefly. I'm aware that 16 minus 5 is 11. I said it was 9, and then I had to correct myself. And similarly, the average of the numbers from 1 to 100 is 50 and a half, not 50. Another way of looking at it is that there are 101 numbers from 0 to 100, and the average of those is 50. And the point is, we were doing that to get to this formula. I think I also said this formula was from Gauss, that he came up with as an elementary school student. I think actually it might have been Euler. I haven't looked that up because I don't think it matters. I guess Euler was much more of a number theory guy than Gauss was, so... but I don't think... The formula... The thing about math, it doesn't matter who came up with it, for the most part. But the nice thing about this formula is, even if we were to say it's 100 numbers and we want to get the average, which is 50.5, so that wouldn't be doable in integer math, because it doesn't come out to an integer. But if you do the multiplication, the number of numbers times the average, you can do the multiplication of the numerators first, and of course one of those numbers is going to be even, so when you divide by 2, it stays within integer arithmetic, so, well, that's just a nice property of the formula, that the divide by 2 was always going to be even, which makes sense, because obviously when you add a sequence of integers, the result is going to be an integer, but that doesn't mean that your formula will have integers at every point, so you have to make sure that you do the multiplication before the division. Let's not bother with the personal stats. Okay, so we did all this because it was fairly simple, so I just tried to get the code down as quickly as possible, and I wasn't really thinking about what the code structure looked like. But of course, we know that we have the reduce function for doing this total here. We could also compute this f right on the fly, and then total these formulas for every D in data by using a map reduce operation. So just for fun, yesterday I did actually go through, and first of all I did compute my median and average just because, right? So, first thing you can do is you can actually do this whole inner part of the loop, computing F, by taking the data and transforming effectively, because each data represents a ship location. So we say for every ship location, tell me the fuel cost. So we're mapping the ship locations into the fuel cost for each ship, right? And this is just what the body of that loop was doing. We didn't assign a variable. We just took the this n here and we computed it twice and we plugged it into the formula. And then once we computed all the fuel cost for every ship, we can do a reduce, which is just taking the sum of all those things. And this was just when I was checking that the positions match the median and average. But once you've done that, and this was part 1 and part 2. That's why I did this twice. But the thing is, once you've done this, you can actually do it for every position and then use the minimum function to just find the minimum fuel cost across every position. So you can do this as effectively a one-liner. So the one-liner, which I have phrased on 2 lines because it would be hard to get it to fit in 80 characters. And I do fit my lines to 80 characters because I'm not a monster. So we can actually say, let's iterate over all the ship positions from the lowest position to the highest position. And then map every ship position to the total fuel cost, which we get from exactly what we were doing above. And then we take the minimum, and then we print that. So there is a one-liner that solves day 7. So, is the one-liner better? I don't know. As I think I might have mentioned before, the closest thing that there is in real life to programming contests is job interviews. And if someone were to ask you this question and you'd spit out this one-liner as a response, you would demonstrate a mastery of the language, which would be very impressive and make you quite hireable. At the same time, I kind of don't want to work with people who write one-liners all the time because they're hard to read. It would take me a while to figure out what this is. They're much harder to test. Even, the kind of silly add a few print statements here or there, where would I even shove it in here? Because there are no statement boundaries. You'd have to add statement boundaries just to add your debugging statements. And if you wanted to decompose it to make it more testable or something, that would also be hard. So I'm not really taking a position on whether the one-liner form better or worse, but there is something to be said for knowing how to write the one-liner version, which is why I took a couple of minutes to actually do it, just to, get myself going. Okay, so all that was a retrospective on day 7. So, day 8. Let's get rid of this. The main thing about day 8 is that I did not understand the problem. I didn't even read to the end. So I'm not sure whether I should describe first what problem I thought it was. Yeah, so the problem that I thought we were solving, I thought there were 14 different 7-segment displays, right? 14. And every line of the input provided you wire activations for each one of those 14, right? And so I thought you needed to somehow figure out, given that we had hundreds and hundreds of lines of these wire activations, I figured that it was our job to deduce from those hundreds of wire activations what the correct wiring diagram was for each one of those 14 different displays. Obviously, if you have only a couple of data points, you can't necessarily figure it out. But I thought that Eric had made sure to present us with enough input to figure out all the wiring diagrams, right? So I had written code that took, so for each one of those positions, there are 7 factorial ways to wire it. So my approach was to start with a set of all 7 factorial number of ways of wiring it. And then for every input, for some particular position, I would say, well, okay, if it were wired in this way, would it correspond to an actual digit? And if the answer is no, then you eliminate that wiring possibility. And the goal is, because 7 factorial is what, 5,000 or something like that? And so, and you can, and every actual activation should eliminate actually a whole bunch of them. So I figured with enough input, you would eventually whittle all the possibilities down to 1 for every single position. So I wrote code to do that. That is a very general solution to this problem that has been presented, but it is not the problem that has been presented. There are much more straightforward ways to solve the problem being presented, including the first part in particular, which I hadn't even read to this part. Where do we get to? How many times digit 1, 4, 7, or 8? I assume 1, 4, 7, 8. The point is 1 has only 2 segments lit up, 4 has 1, 2, 3, 4 lit up, 7 has 3 lit up, and 8 has all of them, has all 7 segments lit up, and those are unique. So all you have to do is count the number of wires that are activated to get the answer to the first part. That's trivial, and if you look at people's times, there are plenty of people who did this in like 5 minutes, because you're literally just counting. I like to think I could have done it in 5 minutes, but instead I spent 40 minutes working out my thing, and then and then when I ran my thing on the inputs, it said that there were no possibilities because, again, I had completely misunderstood what the input was, what it represented. There are not 14 independent things. That's not at all the problem that we have. So the right way to solve the first part was just to count the number of activations in these things on the right-hand side. Fair enough. Part 2, I haven't actually worked out the correct logic to do it. Part 2 says actually what we're getting in the input. The first things are 10 different activations for the 10 different digits for the same set of wiring, right? And presumably, since you can easily look at that and deduce which is the 1, 4, 7, and 8, just from the number of activations. And then you only have a couple of possibilities for each wire where it leads to. The one in particular, you have 2 wires lit up, and so there are only 2 possibilities for each of them, right? So there's probably, if you think it through a little, there's probably some way to deduce from those wiring diagrams what the wirings for the others are, and use that to decode the correct wiring. I didn't bother with that because I had already built this completely general purpose machinery where once I knew these first 10 things are all, different wirings of the digits, well, okay, I can just plug that into my little set, reducer thing and eliminate all the other options. So that's what I did. It's a hugely overpowered approach, but, it got me to the right answer, admittedly quite slowly because it's a complicated way to go. So, just to walk you through the code I had here, let's actually move that so we can look at a whole bunch of the code. Well, the first thing is to come up with all the permutations, and I spent a little while dithering about whether this was built into Swift, and I know there is a module in Python to do it. But I don't know how to do it in Swift, so I had to write my own little recursive, come up with all the permutations of the characters. And the point of each permutation was assume that we have a string A, B, C, D, E, F, G. Then all the permutations of that is a mapping. So A should be mapped to whatever the first position in the permutation is. B should be mapped to whatever the second position is. and so on and so on. And so all the different permutations are all the different ways to wire a 7-segment display, right? So I wrote this little recursive thing to create all these permutations that went into my set of permutations, right? Then I made an array of the correct activations for each of the 10 digits, and it can be indexed by the position of the digit, right? Well, initially, this position thing was from my original solution where I thought there were 14 independent wiring diagrams. As I say, that's not the case. There is a new wiring diagram for each line of the input. So you have to compute the wiring diagram for each line individually when you have, well, you have 14 things you can use to prune the set effectively. Anyway, so that is not used. I could have commented that out. So I have an array of all the digits, and then I actually created a set of all of the and I turned each of these strings into a set of characters. For easy lookup and comparison. And then I just said, okay, let's have a set of all the digits so we can look them up fairly quickly. Probably not necessary because it's a 10-element array. Actually, just scanning it might be faster than looking in a set, but they're hash tables, so maybe the hash table is faster. I don't know. I haven't checked. So what do we do? This is, at least part of my logic for doing this kind of brute force, figure everything out. What I did in practice was say that for every line of the data, right, I said, okay, all perms are all the possible mappings, so let's take each possible mapping in turn and see if this mapping can correctly map every single activation that we see, right? So we take, well, actually, you didn't need to use the first 10, but you only ever need the first 10 to figure this out. You take each one of these things, you turn it into an activation, you translate it, according to this mapping, which we do by indexing based on the ASCII value offset from A. So this is just saying, so when we subtract A will have a value of 0, B will have a value of 1, C will have a value of 2, and that will give us the index into the digits array that we're looking for, right? So we do this mapping. We put that in here, and then we check whether we actually whether these first 10 I'm explaining this badly. So for each one of these first 10 elements, we translate it and then put it into a set, right? And if we get all 10 of the digits correctly put into the set, then what we end up with is exactly the set of digit activations that we started with. So if that is what we ended up with, then we have the correct mapping. And in that case, all we do is, this was cut and paste reuse effectively, with the obvious edits. So then we just translate the last 4 digits using that and then output them. I think for the first part or something, I printed them. No, for the first part, obviously, I counted the appropriate digits if it happened to be 1, 4, 7, or 8. And for the second part, I turned it into base 10, right? Once I had a digit, I computed its value, then added this out val, and then I totaled up all the out vals and printed them. So, I ended up being astonishingly slow on the first part, and it was only a couple of minutes later to finish the second part. And again, that was because I spent, it was 45 minutes in when I actually read what the problem was. And that includes 10 or 15 minutes trying to debug why I was whittling myself down to sets of 0 because I had completely misunderstood what the input was. So, anyway, that's my little recap on how day 8 went. And we will, I guess, reflect probably quite briefly because I'm a little worn out from I didn't get this recording and now I have to do a second one and it's a lot of time. And now I'm probably going to figure out how to use a different software tool to record these things in the future, and I might even try live streaming. I think I enabled my YouTube account for live streaming earlier, so it's possible that a live stream will happen either tonight or tomorrow. We'll see. Anyway, so I'll see you then.